This is Algebra 2. Test number should say 14. Test number 14. We're going through section 6.3. Test 14, section 6.3. We're simplifying the difference of these polynomials. First thing, remember, you can only add like terms. Like terms means it has the exact same variable. All of these have x, so that's the same. But it's also raised to the exact same exponent. So you can only add and subtract numbers that are raised to the same exponent. You always want to do the largest exponent first. So 4 is the largest one first. So negative 5x to the fourth power. That's referred to as the degree of x. The degree is 4. Negative 5x to the fourth minus negative 7x to the fourth. Minus the negative means plus. So negative 5 plus 7 is 2x to the fourth. That's the first part you do. All of this is really easy, but if you're messy or sloppy or anything like that, you might make a mistake when you write it or when you record it, what you're trying to do. The next degree is x to the first power. Notice there's no x to the thirds or x squareds. So negative 7x, again minus negative 9x. Minus a negative means plus again. So negative 7 plus 9 is positive, that's why you put a plus there, 2x to the first power. And then the constant terms come last. 5 minus again, negative 5. 5 minus a negative 5 means 5 plus 5, which is positive 10. So there's your first polynomial, 2x to the fourth plus 2x plus 10. Number 2 says negative 5w squared minus 8w minus 7 minus again 8w squared plus 6w minus 2. Everything's in the it's in the correct order now. Going down, it's in standard form, meaning the highest degree, and then it's counting down. So you do the biggest one, 5w squared minus 8w squared. 5 minus 8 is negative 3w squared. The next one is w to the first power, negative 8w minus 6w. So this is one way. It's negative 8 minus 6 is going to be negative 14. Think of a number line if you have to, w. And then negative 7 minus a negative means plus. Negative 7 plus 2 is minus 5. There's your polynomial. Negative 3w squared minus 14w minus 5. Number 3 says simplify the sum. Notice the difference between 1 and 2, and then number 3 is now we have a plus in the middle. So we're going to do whatever it says after it. The only thing you have to do regarding the order is you want to make sure it's written in standard form. The highest degree is first, and then it counts down, meaning u to the third is going to be first in this one. This one's all in standard form order already. 7u to the third plus 2u to the third. You add 7 and 2, and you get 9u to the third. Notice we're not adding the exponents or multiplying the exponents or anything. We're just simply adding the coefficients, 7 and 2. Then 3u squared plus a negative 8u. Okay, notice right there, I underlined that one by mistake. There is no u squared on the right. So you write the next one plus 3u squared. We didn't do anything to that one. All we did was wrote it. There's only one u to the first power, negative 8u. So you simply write negative 8u. Notice we didn't change either one of those because you didn't add or subtract anything with those. And then you simply add 7 plus 8 is positive 15. 9u to the third plus 3u squared minus 8u plus 15. Number 4, you're simplifying the product. Now you're distributing these numbers. Now, since you're multiplying the same bases in a second, you're going to add the exponents. So distribute 2n times n squared. 2 times 1 would be 2. N to the first power times n to the second power. You add n to the 1 plus 2, and you get n to the third power. Distribute it to the next one. 2 times 3 is plus 6. N to the first plus 1 is going to be n squared. And then distribute 2n one more time to 4. 2n times 4 is plus 8n. Do the same thing with number 5. 3p to the fourth times 4p to the fourth. 3 times 4 is 12. P to the fourth times P to the fourth. You add them, you get P to the eighth. Distribute 3P to the fourth times 7P to the third. 3 times 7 is positive 21. P to the fourth times P to the third, you add 4 and 3 to get P to the seventh. 3P times 4P. 3 times 4 is positive 12. P to the fourth plus P to the first power. Remember, there's nothing shown. That means it's to the first power. You get P to the fifth power. And then the last one, 3P to the fourth times 1 is positive 3P to the fourth. Again, all of this is very, very simple, but it's very, very tedious with a lot of chances to make a mistake. Number 6, we're still distributing 5x to the 7th times 8x to the 7th. 5 times 8 is 40. X to the 7th times x to the 7th. You add 7 and 7 to get x to the 14th. Distribute 5 times 3 is positive 15. Now you have different exponents now. Here's an example where you have x to the 7th and y to the 3rd. Those are not the same bases. So what you have is x to the 7th and y to the 2nd, and you write it just like that. You don't add 7 and 2 because they're not the same bases. You don't get 9 there. 6 times 6, you get 36. 8 to the 7th times 8 to the 4th, same base. You add 7 and 4 to get a to the 11th. 6 times negative 8 is negative 48. Again, here's another instance where you have a to the 7th and b to the 6th. You don't add them to get 13. They're different bases. A to the 7th, b to the 6th. Very simple. If they're not the same base, you do not add the exponents. Number 8, 5a squared times 3a to the 4th plus 3b. 5 times 3 is 15. A squared times a to the 4th. You add the exponents 2 and 4 to get a to the 6th. 5 times 3 is plus 15. Again, here's an a squared and a b. You don't do anything with those except write them as a squared b. You don't add up 2 and 1 to get 3. 8 times negative 3 is negative 24. P to the first power times p squared is going to be p to the 1 plus 2, which is p to the third. 8p times 6p is plus 48. P to the 1 plus 1 is going to be p squared. And then 8p times negative 2. 8 times negative 2 is negative 16p. And again, you notice as we're looking at all of these, there's no like terms that you can combine. If we had had negative 24p to the third plus 48p, if that was to the third, we'd have to put those two together. But since they're not, all you can do is write them side by side, not like terms. Number 10, anything raised to the 0 power is 1. Doesn't matter what it is, anything raised to the 0 power. Number 11, anything raised to a negative power needs to ride the elevator. Remember, everything is considered to be over 1. Since it's being raised to a negative exponent, it has to ride the elevator to the bottom. Since there's nothing left at the top, you can't represent it with 0 because then the whole thing would be 0. You'd have to represent it with 1. When it goes down, it stays negative 2. That negative doesn't change. But the positive, the negative 4 exponent changes to a positive 4. So you have 1 over negative 2 to the 4th power. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. Times negative 2 is positive 16. 1 over 16 is your simplified answer. 12 over a to the negative 7th, b to the 0 power. Okay, what we have here is we have something being raised. It's a 9th power. Okay, something's being raised to the 9th power. That says to the 9th. Let me write it a little bit bigger where we can see it a little better. A to the negative 7th, b to the 9th. Okay. The only thing we can do with this is we can make the thing that's being raised to a negative ride the elevator. Remember, anytime something's to a negative exponent, it can't stay wherever it is. If it's at the bottom of a fraction, it has to go up. If it's at the top of a fraction, it has to go down. This one's at the bottom, it's got to go up. Notice 12 doesn't move, it stays at the top. 8 comes up, and since it was to the negative 7th, it becomes to the positive 7th. B doesn't move, it stays right where it is. B to the 9th. This is all you can do with this one. Move that 8 to the negative 7th up. Number 13, you're multiplying all of the same bases. So 3 times 3 times 3. You add negative 3 plus 5 plus 5. Negative 3 plus 5 is 2, and 2 plus 5 is 3 to the 7th, and we're going to leave it like that. You can possibly do 3 times itself 7 times and get a great big number. We'll leave it like that for right now, though. 4.48 to the negative 7th times 4.48 to the positive 7th. Same bases again. Add 4.48 to the negative 7 plus 7, and you get 4.48 to the 0 power. We know from a little while ago, anything to the 0 power is 1. Okay, there's a 1 here that's not written. When you multiply 1 and 4, you get 4. Then you multiply in the same bases, x times x. So you do x to the negative 3 plus 6. That gives you 4x to the negative 3 plus 6 is going to be x to the 3rd. Number 16 says negative 2g to the 8th power times 5h to the 10th power times 6g. Multiply all of your coefficients. Negative 2 times 5 is negative 10. Negative 10 times 6 is negative 60. So we got negative 60. Then multiply all of your same bases. G to the 8th times g to the 1st means g to the 8 plus 1. And then you have one more base that's different, h to the 10th. Notice there's nothing multiplying times that one. So all you can do to simplify this one is negative 60. G to the 8 plus 1 is g to the 9th, h to the 10th. Now we're raising powers to powers for number 17. Raise everything to the 4th power. 5 is raised to the 4th power. And n squared is being raised to the 4th power. Anytime you raise a power to a power, you're not adding them anymore. Now you're multiplying 2 times 4. So 5 to the 4th power means 5 times 5 is 25, times 5 is 125, times 5 more is 625. N to the 2 times 4 is n to the 8th. Number 18 says a to the 9th over a to the 10th. Remember, multiplication meant you had to add the exponents. Division means you need to subtract them. So you have a to the 9th minus 10 is a to the negative 1. We can't leave it like that. You can't leave a negative exponent. Everything is over 1. Since it's over 1, have it ride the elevator down. You can't leave nothing at the top. You have to leave 1 at the top. A comes down and it's to the positive 1. You don't have to write anything to the positive 1. You can simply leave it as 1 over a. 19 says 2 to the 10th over 2 to the 12th. Again, same thing, same basis. Subtract the exponents. 2 to the 10 minus 12 is 2 to the negative 2. Can't leave it at the top with a negative exponent. Everything's over 1. It rides the elevator. It goes down. 1 stays at the top. 2 goes down squared, which becomes 1/4. Okay, you have 2 exponents now. I'm sorry, 2 different bases. One's j and one's k. The first one says j to the 9th divided by j to the negative 3rd. When you're dividing exponents, you subtract. When you're dividing bases, you subtract exponents. Minus a negative 3. Minus a negative 3 is going to mean plus 3. So j to the 12th. And then k is k to the 3 minus 8. You subtract 3 and 8. And that gives you k to the negative fifth. Remember, you can't leave a negative exponent. Everything's over 1. The only thing that's being raised to a negative value is k. So this is going to ride the elevator down. J stays at the top to the 12th over k goes down to the positive fifth. It goes from negative to positive. 6k over 5 squared. Everything gets squared here. 6 gets squared. K gets squared. And 5 gets squared. 6 squared is 36. K squared, we don't know what that is. We'll leave it like that. 5 squared is 25. There's no number that goes into all of that. 36k squared over 25. '22 is just solving these equations. Now we're getting back to quadratics. X squared plus 8x plus 16 is equal to 81. You want it to make it equal to 0. Okay, instead of making it equal to 0, this is one of those instances where you're going to have to complete the square right here. So move 16 over by subtracting 16. If you subtract it there, subtract it on the right. 11 minus 6 is going to be 5. 7 minus 1 is going to be 6. So what we have is x squared plus 8x plus c is equal to 65. Remember, we want to get a new value for c. In order to find c, you take b divided by 2 and square it. B's value is 8, so c equals 8 divided by 2. C is 4 squared, so c's new value is going to be plus 16. If you add 16 to the left, you have to add 16 to the right. So what we have now is x squared plus 8x plus 16 is equal to 81. So we're getting right back to where we were a minute ago. Okay, I'm not sure why I did like that. But this is how we're going to do to solve it. That's why I hesitated for a second. This is a perfect trinomial right here. Since it's a perfect trinomial, you can take the square root of a. Okay, that gives you x. You could take the square root of 16. That gives you 4. This sign tells you what to put in the middle. X plus 4 squared equals 81. In order to get x by itself, you undo squaring something by taking the square root of it. If you do it there, do it here. It'll cancel it out and give you x plus 4 equals the square root of 81 is both 9 and negative 9. Here's one of those instances where you're going to come up with two completely different answers. In order to get x by itself, you subtract 4, subtract it from this one and this one. So x's value is going to be 5 and negative 13. Two separate answers that when you plug in, you're going to get a correct answer. Simplify number 23. Distribute 4 times y and 4 times 4. Okay, this is just an algebra 1 problem. Get all your y's by itself. Negative 4y, negative 3y is smaller than 4y. Bring it over by adding 3y. If you add it there, add it here, you get 7y. This cancels out 14. Move negative 16 over by subtracting, positive by subtracting it. 14 minus 16 is negative 2 equals 7y. This cancels. Get rid of 7 times something by dividing by 7. Y is equal to negative 2 over 7. Again, distribute 4 times y. 4 times 2. Undo addition first by subtracting. Undo multiplication next by dividing. Y is 7. '25 tells you to factor the expression ax squared plus bx plus c. Remember your c values or what you're looking for. X times x. What are your factors of 15? 1 and 15, 3 and 5. Which pair is going to get you to b? The only pair that's going to get you there is 3 and 5. This one tells you that they're opposite signs since it's negative. This one tells you the bigger absolute value is negative. Negative 5, positive 3. The square root of negative 16 plus 6. Remember, make it say a plus bi. In order to take this out, you have to multiply it by I. So the square root of 16 is both 4 and negative 4, so plus or minus 4 times I plus 6. And in order to make it say a plus bi, just reorder these two to make it say 6 plus or minus 4I. 27 says solve it by completing the square. Here's one of those instances where we have to move this value of c over. It won't give us a perfect square like I did a little while ago. I didn't have to do it, but I did it just out of habit. X squared plus 14x plus c equals negative 60. Find your new value of c. That's b divided by 2 squared. B's value is 14 divided by 2 is 7, not 17, is 7. And 7 squared is positive 49. If you're going to add 49 to the left, add it to the right as well. Negative 60 plus 49 is going to be a negative 11. And then take the square root of a and you get x. Take the square root of 49, you get 7. This tells you to put plus in the middle of them. X plus 7 squared is equal to negative 11. Get rid of squaring something by taking the square root. If you do it there, do it here. X plus 7 equals I times the square root of 11. Remember, you have to get rid of that negative. So the last thing you have to do to solve it, subtract 7 on both sides. And if we write it in a plus bi form, x is equal to negative 7 plus or minus the square root of 11 times I. Number 28, rewrite it in vertex form. Vertex form, y is equal to a times x minus h squared plus k. All you need to do is move plus 5 over by subtracting it. Y minus 5 equals x squared minus 6x plus c. We're going to find our new value of c. Negative 6 divided by 2 squared is negative 3 squared, which is positive 9. If you add 9 to that side, you have to add it to this side. Y plus 4 equals, undo x squared by taking the square root of it, undo positive 9 by taking the square root of it. This is the sign that goes in the middle. That binomial squared, x minus 3, is equal to that perfect trinomial. Last thing you got to do to make vertex form is get rid of that positive 4 by subtracting it. And y is equal to x minus 3 squared minus 4, vertex form. And remember, if it asks you for the vertex out of that, it's the opposite of what you see here. So it would be 3 as your x value, and exactly what it says here, negative 4 as your y value. That's where you would graph the vertex. 29 says use a quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Everything's in standard form already. So negative b is, this is b's value, negative 1. This is a's value, negative 1. Negative b will be positive 1. Negative negative is a positive, plus or minus the square root of b squared. Negative 1 times negative 1 is 1, minus 4 times a is negative 1, times c is negative 3. All of that's over 2 times a is negative 1. So negative 4 times negative 1 is 4. 4 times negative 3 is negative 12. You have the square root of 1 minus 12, which is negative 11. 1 plus or minus that over 2 times negative 1 is negative 2. There's only one more thing you can do to this. Get rid of the negative inside of the radical by saying 1 plus or minus the square root of 11 times I over negative 2. And that's your value of x. 30 says solve by finding square roots. Divide by 3. X squared equals 10. Get rid of squaring something by taking a square root. X equals the square root of 10. So X equals positive or negative square root of 10. (31) says simplify by rationalizing the denominator, the square root of 15 over the square root of 15. 3 times the square root of 15 over, you'd multiply those two together, and you'd come back to the radicand, which is 15. You have to simplify this. Don't leave it like this. 3 goes into itself once, and it goes into 15 5 times. So the square root of 15 over 5. Number 32 says to multiply, you have to FOIL this. FOIL means first two terms. 3 times 8 is 24. Outer two terms, 3 times the square root of 6 is positive 3 square root of 6. Inner two terms, negative square root of 6 times 8 is negative 8 square root of 6. And L, last two terms, negative square root of 6 times positive square root of 6 is negative square root of 36, which is going to be negative 6. Put your like terms together. Your like terms in this case, 24 and negative 6 is going to be 18. And 3 times the square root of 6 minus 8 times the square root of 6 is negative 5 times the square root of 6. And that's all you can do with that.